Right, welcome to a concept video on measurement of angles. I've seen many students struggle with this simple concept. It's just how angles are measured, right? And I think we know what angles are. It's basically we have a full direction here in 2D two-dimensional plane. So every direction here into the 2D plane can be measured in terms of angles. So for example, this could be 0 degrees if we're taking an angle from this x-axis here and make an axis here. And if we measure from this axis, this could be 0 degrees. And similarly, this could be 45 degrees or something else, right? So this is basically angles. Here I'm using degrees, which we are very familiar with, but there are other measurements of angles which I would like to get into with this video. All right. So usually when there's angles, there's a number given and there's some symbol that tells you what the angle is. So here in this case, this circle looking thing means this angle is in degrees. For example, 30 degrees, 0 degrees, 90 degrees. For example, this is a 90 degree. And a 90 degree is actually very useful because it is the uh, angle between two perpendicular lines. So, for example, if we have a line here, then we have an upright line, like how you stand on the on a flat ground, right? So that's what we call a perpendicular line. So this, if this line is A and this is B, clearly uh, this line and this line are perpendicular, and this angle between this perpendicular lines is a 90 degree, which is denoted by this box looking angle, right? Usually when we have regular angles, we denote it with this circle looking thing. So if you measure this angle from the z dash axis, then yeah, we have this circle. Because but when it's a 90 degree, which is a very useful angle, right? We have this box looking depiction here. All right. So yeah, degree is degrees. So I would like to tell you about degrees, even though you might be familiar with them. So if we have a full direction, like a circle, let me get a circle here. Right, here's a circle. It's not perfect. Something like this. All right. So if we have a circle, and then we try to divide this circle equally in parts, right? So let's say you try to divide the circle. I'm not doing a great job at it. Now it's divided into four equal parts for now. All right. So let's keep dividing. If we divide this into 360 equal different parts, one of these parts is going to be an angle. So yeah, you're gonna have a lot of divisions here because there's 360 divisions. So yeah, that angle that we get, this one part that we get here, is a degree angle, right? The one that we're most familiar with. So a full rotation is 360 degrees. And we define this to be 360 degrees. Why, you may ask? Because 360 is a number that is very useful. It's a composite number that has many prime factors. So you can easily divide this number many times, which is made apparent by its prime factorization. So let me try to divide 160. Let me try to write its prime factorization. So as you can see, you have many factors of 2 here, the factor of 3 here, another factor of 3, and a factor of 5. So as you can see, you can divide it with 2, and you can divide it with 2 3 times, divide it by 3 2 times, and you can even divide it by 5. So that's why 360 is preferred when we define this angle, right? So that's it, our degrees. There's another similar unit that is called grades. You have probably never heard of this, and hopefully you never come across this. But if you're unlucky, you might come across this measure of angle. So yeah, just so you don't get confused, I'm going to teach you here. Usually, when we learn about these different units of angles, we like to think about them in terms of right angles, right? So I already told you what a right angle was. So if we have a right angle, that's 90 degrees in our degree measurement of angles here, the first, and a grade, and in the grade measurement, right, we simply have, in a right angle, we simply have 100 grades, and that's depicted by this G on top that stands for grade. The angle has a circle, in degrees has a circle. So yeah, if a right angle is 100 grades, you can remember them in terms of right angles, all right? Like a right angle of our degrees is 90 degrees. A right in grades, a right angle is 100 grades. So complete angle, like a circle, full circle, that's 400 grades. Here it's 360, of course, 360 degrees. So yeah, you have to divide this by 400 into 400 equal pieces, and one of that piece, one of those is a grade. So yeah, this is very uncommon. You might have heard of this. And there's one very useful unit that you might have heard of, and you're going to need to know this. It is sometimes written with this C on top that probably stands for circle. You could imagine that this is called radians, by the way. Let me write that first. So just by the C, maybe it's apparent the connection of radians as a measurement, as a unit with the relations of it with circles, right? So let me try to bring this to you in a intuitive way. If we have a circle, which is basically a full angle, right? We know what pi is, right? Pi is the constant, the proportional constant of any circumference which is radius, like of a circle. So if you have a circle with with r radius, then the circumference, this length of the circumference, let me write it like this. This length is always going to be twice pi r, because if you have the denominator, that's twice r, right? Not the denominator, sorry, the diameter. So diameter times a constant that is pi is the length of the circumference. So circumference is 2 pi r. It's defined like this. If you multiply the diameter of a circle with pi, you get its circumference. So that's the definition of pi. One useful definition of pi. So let us pick some a radius here. If we're trying to define radians, let us use a circle and pick a radius. So what radius would we pick here? I would say we start counting from one, right? So one is unity. Clearly, it's intuitive to pick one as a base circle to work with, right? So that's why we pick one unit as the radius of the circle. This is called a unit circle, right? This is very useful in math. So what will be the circumference of this circle? Clearly from the formula that you might have studied, if we put r as 1 here, then we get 2 pi units. So you could say the circumference length is 2 pi. So let me just write that down. over here, and units, I guess, whatever. So what radians is basically, you can understand from here, is that 2 pi radians is basically a full uh, angle here. So this whole circle is 2 pi radians. So based on that, let me write it over here, 2 pi radians. Sometimes radians is written with the C here, sometimes not, because it's such a common unit in some fields like calculus, trigonometry. You might not see a C like this written. Usually it's not written with one, but in those cases, you can usually assume that it's in radians. So for example, if you have sine 0.58, for example, like clearly that's degree is not given here or grade, nothing like that is given here. You can assume that this is talking about 0.58 radians. All right. This is a very useful measurement, very useful unit, radians. So if the whole circle is 2 pi, a right angle will be 1/4 of that. So clearly it's going to be 2 pi by 4, which is pi by 2 radians. So right angle in radians is pi by 2. I'll teach you one useful conversion that is needed to convert angles into radians or radians into angles. Although you could always convert them based on what you learned here with this right angles and this full angles, intuitively you may able to already be able to convert them, but I'll still tell you the formula. So for example, you want to convert, let me take some examples. Let's say you want to convert 30 degrees with this 0 here, that means degrees, into radians. So how can you convert 30 degrees into radians? How many radians is 30 degrees? So usually, the formula for this is going to be 30 into pi by 180. So whatever, so let's say you have any angle, right? Any angle in degrees times pi by 180 is going to be the radians conversion, right? Because we can see that pi is clearly 180. The pi radians is 180 degrees. So it's a conversion here. You can see. You could also do like 2 pi by 360 if that makes more sense to you, because that's a full angle. 2 pi, that's a full angle in degrees, right? You can see that degrees and degrees, this number, this degree and degree cancel out to give you the angle in radians. Um, this is C, of course. So if that makes sense to you, that's great. You could also you could also think about it like this. If a right angle triangle is 90 degrees, that's 1/3 of 90 degrees. So that's 30 degrees, right? And if pi by 2 is in radians, like in radians, a right angle is pi by 2, then a third of that, which is this times 3, right? So that's pi by 6. So in radians, you could see that uh, 30 degrees is going to be pi by 6. That's just a third of this angle, 30 degrees. So you think of it like that. But that's why I taught you this entire thing about measurement of angles, right? But this formula is very handy to do it casually like this. So yeah, 30 degrees, if you put in 30 here, degrees, and then here's radians, and here's the this. So 30 degrees. So 180 divided by 30 is clearly 6, right? So that gives you 6 here. Pi by 6 radians. So 30 degrees is pi by 6 in radians. Alright, I hope you will be able to convert these units. And obviously, clearly you can see that if you wanted to convert any number, any angle in radians into angles, then you multiply by 180 degrees by pi radians. You see that you get it in degrees here. Overall, you get it in degrees here. So you just flip this. So this converts any angle in radians into degrees. So yeah, similarly you can do it for grades, right? Like if you convert radians into grades, then you could say, oh, let me just get pi and uh, this is radians. So we want to get rid of that. And how much is pi radians in grades, right? So I said pi is 180, right? Pi is 180 in radians. So this is 180. 180 is sorry, pi is 180. Pi radians is 180. And grades in a right angle, there's 100 grades. So in a 180-degree angle, there are 200 grades. So based on that, if you want to convert radians into grades, then you have to multiply by 200 by pi, right? Simple. So this gives you your angle from radians to grades. So hopefully you could intuitively think of these formulas based on how I taught you here. One other thing I would like to get into before ending this is minutes and seconds. You might not be familiar with them, but basically we have 360 angles, right? So sometimes for degrees we have 360. Sometimes we like to talk about a very small part, a very small angle, like even smaller than 1 degrees, right? So maybe you could, you could get a half a degree, right? Sure, that works, but this is not very useful. The whole point of this was to like make this intuitive, right? This degrees, this measurement. So yeah, we could say this like 0.5 degrees is a thing, but we could write this in a better way when we're dealing with small angles. For example, here we can say one angle is 60 minutes. So you can think of an angle like an hour in a clock, right? So 1 hour is 60 minutes. You're familiar with that. And we can even further divide. So basically now we can say that 360 degrees is like 360 times 60 minutes. So that is a lot of divisions you can work with here now. And these minutes are, written with these dashes, right? Single dash or apostrophe, whatever you like to call it. So yeah, let's divide this minutes into even smaller units. So maybe like 1 minute, we could say 1 minute is 60 seconds. The seconds are written with double dash. So this is a very useful conversion. So let's say I told you to tell me how much is let's say 3.2 degrees, right? So I don't like this point 2. I want 3 degrees and then this point 2 to be in minutes. So that would be very intuitive to me. So 3 degrees is fine, that's full angles. But this is 1/5, right? 1/5, this point 2 is 1/5 of this. So you could say 3, you could write 3 plus point 2 like this, right? So that's 3 degrees. And this is 0.2 degrees. But we want to convert this like this. So if you divide this both sides by 5 here, then get 1/5, which is 25, 0.5, sorry, 0.2. Then you get divide this by 5, which gives you 12. So you get 12 minutes. So yeah, if you divide 60 minutes into 5 parts, then you get 12 minutes. So this could be written as 3 degrees 12 minutes, like this. So that's how we use this minutes in degrees. These are the conversions, just like with a clock. The grades has uh, minutes and seconds as well, but it's not 60 minutes. 60 minutes is not one grade. We have one grade equal to 100 minutes because this is a decimal system. We have defined it to be 100 grades, a right angle, to be 100 grades. So you can say that one grade is 100 minutes, and 1 minute is 100 seconds. So that's how we convert minutes and seconds in when we're using grade as our unit. This is not very useful. Doesn't come up that often. The radians, we don't really use this minutes or seconds. It's simply radians, and you can see this in decimals. There's like point 0.5. There's like crazy decimals like point 2172 radians. That's fine. That's totally fine. You'll probably encounter this kind of thing. You get decimals and angles and grades too, but this is very useful whenever it comes up. That's it. That's all I had to talk about uh, regarding measurement of angles. Hopefully that made sense to you. Hopefully I made it intuitive. All right, signing off.